Now that you know how to solve a radical equation with one radical, we're going to look at what if you have more than one radical. Specifically, we're going to look at what if you have two radicals. So if you have an equation that contains two radicals, remember that a radical is the same thing as a rational exponent. So 1/2 is the same thing as square root. 1/3 is the same thing as cube root. So it can be written in either way, either form. What you're going to want to do is you're going to want to isolate one of the radicals. That means get one of the radicals on one side of the equation by itself. You cannot have both radicals on the same side. You have to get one radical by itself. So we're going to look at, I have a total of 3 examples. 1 and 2 are going to be slightly different. Example 3 is going to be very similar to example 1. That's a good one for you to try on your own, or if you feel like you get it, then feel free to just watch the first 2 examples. Looking at example 1, so the first thing I see that I have to do is I have to isolate one of my radicals. Doesn't matter which. Let's say I decide that I'm just going to isolate the first one. Well, in order to isolate that and get it by itself, I'm going to have to move the other one to the other side of the equation. So I'm going to add a square root of 2x plus 7 to both sides, giving me square root of 3x plus 2 equals the square root of 2x plus 7. From here, I'm going to follow all my same steps from when I had one radical, and I'm going to put all those steps towards this radical equation here. So the one I isolated, in order to get rid of the radical on the variable that I isolated, or the equation that I isolated, I'm going to go ahead and square it, which means I also have to square the other side. Well, my square root and my square will cancel on both sides, leaving me with 3x plus 2 equals 2x plus 7. Now this is a linear equation, so I'll collect my x terms on one side. I'll subtract 2, and I get x equals 5. And if I were to plug it back in, notice I would get 15 plus 2x, so I'd get the square root of 7. 10 plus 7 is the square root, I'll get the square root of 17. I'll get the square root of 17 here. Square root of 17 minus square root of 17 will give me 0, so that does work. Looking at the next example. Notice that I have a 0.5 and a 0.25. What's that going to do? And actually, you know what, before I look at this one, I want to talk about something on this one. Sorry. I want to point out that the biggest mistake that I see that people want to do is they say, hey, I'm just going to square both sides, and then I'll distribute my square in. Please, please, please remember, you cannot distribute an exponent unless you have multiplication. So if I were to do this, it does not distribute and cancel. This would mean I would have to write this expression twice and use FOIL. That sounds terrible. Do not do that. Make sure you get one of the radicals by itself on one side. So now moving on to example 2. So I look at this and I might freak out because there's decimals, and we know how to do with radicals, and we know what to do with fractions, but we don't know what to do with decimals. Well, I know how to change decimals to fractions, especially these ones. These ones are pretty easy. So I'll have 2x plus 1 to the 1/2 equals 3x plus 4 to the 4th. Excuse me, to the 1/4. To the 1/4, since my 0.25 is the same thing as 1/4. So now from here, I'm supposed to isolate a radical. Well, these mean radicals. This means square root. This means 4th root. So I already have a radical by itself. So in order to get rid of that radical, or to get rid of that fractional exponent, I'm going to raise both sides to the same power. I'm going to pick the power that will actually get rid of all the radicals. So if I squared this side, it would get rid of the 1/2. If I put a square over here, this would reduce to 1/2, and I would still have a radical. So I'm going to pick the larger of the two denominators to raise both sides to. I'm going to raise both sides to the 4th power. When I do, those will cancel. These will multiply because I multiply power to a power. 4 times 1/2 is 2. So I will have 2x plus 1 squared equals 3x plus 4. Well, now if I want to solve this, I can't solve it if I have an x inside a parenthesis and an x outside a parenthesis, because I'm going to try to figure out what x is. So I'm going to go ahead and square this. So I'm going to do a little bit of scratch work over here. 2x plus 1 times 2x plus 1, because squaring means write it twice. I cannot distribute into plus. I get 4x squared plus 2x plus 2x plus 1. Combining my like terms, I get 4x squared plus 4x plus 1 equals 3x plus 4. Well, notice that this is a quadratic equation. In order to solve quadratic, I have to get it equal to 0. Once it's equal to 0, then I can either factor it or I can use my quadratic equation. So I'm going to go ahead and subtract 3x and subtract 4 from both sides. And my new equation is 4x squared plus x minus 3 equals 0. I don't know, I don't want to factor this, so I'm going to go ahead and say then x equals negative b plus or minus the square root of b squared. Remember, there's a 1 in front of the x if it's not written. Minus 4 times a times c all over 2a. Cleaning this up, I get negative 1 plus or minus a 1. Negative 4 times 4 is negative 16 times negative 3 is plus 48. All over 8, which gives me negative 1 plus or minus. I can see I'm running out of room a little bit, so I'm going to skip a step. I know that this is going to be 1 plus 48 is 49, and I know the square root of 49 is going to be 7. So I end up with negative 1 plus 7 over 8, which is 6 over 8, or 3/4. And I also get negative 1 minus 7 over 8. Negative 1 minus 7 is negative 9 over 8, and that does not reduce. Negative 1 minus 7 is negative 8 over 8, which does reduce to negative 1. So I have 3 over 4 and negative 1. But if you remember from before, if I square a variable, I have to check for an extraneous solution. So I'm going to plug both of these answers back in. So if I plug them back into my original problem, I have the square root of 2 times 3 over 4 plus 1. Does that equal the fourth root of 3 times 3 over 4 plus 4? Well, 2 times 3/4 is 6 over 4. I'm going to go ahead and rewrite 1 as 4 over 4, so it has a common denominator. Well, 6 plus 4 gives me 10 over 4. And the square root of 10 over 4 is the square root of 10 over 2. We're doing the same thing over here. I get the fourth root of 9 over 4 plus, again, I'm going to anticipate that I'm going to need to have a common denominator. This is 4 over 1, so I can call that 16 over 4, which gives me the fourth root of 16 plus 9 gives me 25 over 4. So I need to know, are these equivalent? So I can get rid of the radical on the bottom by multiplying by square root of 4, square root of 4, square root of 4, or excuse me, 4th root of 4, 4th root of 4, 4th root of 4, so I have a total of 4 of them. I'm going to put each of these into my calculator and see if they give me the same value. When I put this into my calculator, I'm going to enter it into my calculator as 25 over 4 to the 1/4, because I can do the exponent on my calculator. When I do that, I notice I get about 1.581 here and about 1.581 here. So 3/4 did work as a solution. I'm also going to have to check negative 1. So let's see if I can move it up enough to see what my original problem was. So I will get the square root of 2 times negative 1 plus 1. Does that equal the fourth root of 3 times negative 1 plus 4? Well, that gives me square root of negative 2 plus 1. Does it equal the fourth root of negative 3 plus 4? Well, I can already see that this is going to give me something that is not a real solution, because I'm going to end up with the square root of negative 1, which is not a real solution, and the square root of 1, so those will not, or excuse me, the fourth root of 1, so that will not work. So 3 over 4 is my only solution. So like I said, on the third example, which I'm going to show in just a moment here, if you feel like you understand it, you can stop the video now. If you feel like you're not quite sure if you're getting it yet, please watch example 3. You may even want to try example 3 once on your own before watching how I do. Okay, so here's example 3. So again, go ahead and pause it and try it if you'd like. Now that you've had a chance to try it, I'm going to go ahead and isolate one of my radical expressions. I know that this is the same thing as the square root. So if I want to isolate one of them, I'm going to add one of them to the other side. Giving me 3x minus 5. I can either write it to the 1/2 or I can put it under a radical, whichever you prefer. X plus 3 to the 1/2. To get rid of a 1/2 power, I'm going to go ahead and square both sides. When I do, those cancel, and these cancel as well, leaving me with negative 3x minus 5 equal to x plus 3. I'm going to go ahead and get my variables on the same side, leaving me with negative 5 equals 5x plus 3. I'm going to subtract 3, giving me negative 8 equals 5x. I will divide by 5, and I get x equals negative 8/5. That is how you solve radical equations that have more than one radical.